Hello. Yeah. Back with another sweat session, and let's do this integral. And that is integral 0 to 1 x to the minus x dx. Now, I showed you how to integrate x to the power alpha times x to the beta. So basically, we have done a more general version of this is what I'm telling you. So I was gonna do this video really short and then link that other video that showed the more general result and be like, yeah, watch the link. And then I thought like, yeah, you might not like that. And so, yeah, I care about you. And I do actually. No. And yeah, so let's do this. And so in a way, like, you know, we're kind of repeating ourselves, but the result here is quite nice. It's very clean, and so yeah, let's get on with it. So how do we start? Well, same old. So we know we could write x to the minus x as e to the minus x times the natural log of x. Yeah, and then we use the series expansion for e, and write that this is the same as n equals 0 to infinity, and then x times negative ln of x to the power n over n factorial. Right? Okay, and of course we need integral signs and stuff, and yeah, we'll do that in a second. First, this is x to the n, and then yeah, I could do this, right? Like, that's fair. And then this here I could write like here, right? Yeah, okay. And so this is supposed to be like dx and dx 0 to 1. So aquí 0 to 1. Yeah, and we've said in similar videos like small sigma and capital sigma can swap places. It's just the integral rule. Sum of the integrals is the integral of the sum, right? Okay, and of course dx. Okay, and now let's do a substitution. And the substitution is let's let u equal this. Plus, notice that this is the same as dot, right? And then that means that we've got u to the n here, right? And also that negative u is equal to ln x, no, the natural log of x, or ln of x. Ln, I kind of get irritated when people say ln. It's not ln, it's not a she, it's an it, and it's ln. Yeah, okay, there we are. What else? Oh yeah, du, right? Du, Jesus Christ, I'm sweating so much. Okay, du is like the derivative of this, same as the derivative of this, but easier to do like with that. So it's 1 over x, right, like that to start. And so this is the same as x, and then by chain rule, the derivative of 1 over x, negative 1 over x squared, and then dx, right? Am I trying too hard? Am I trying too hard to be likable? Perhaps. Okay, so what does this turn into? It turns into negative 1 over x dx, like that, right? We all want acceptance and being liked, don't we? Frankly, don't care. Only really care about the Lord approving of me. And yeah, by the way, like one kid who's from like MIT wrote on the MIT integration B videos that I make, this is MIT. You don't have absolute values around the natural log. First of all, it's not MIT, it's YouTube. Second of all, I have a video where I talk about why it's important to have absolute values around the natural log, so watch that. And third, perhaps that's why, like, you know, I like people who are not from MIT, because MIT people, like, as amazing as they are, tend to be very, like, super structured and anal to a point where it's actually counterproductive. There's such a thing as being too structured. Okay, anyway, I have to vent. I have no friends. 0 to 1, like this is about x. So when x is 0, we get natural log of 1 over 0. That's like natural log of infinity. We've done this before, so you should follow. That's infinity. And 1 turns into 0, natural log of 1. But as you'll see, my replacement for dx has a negative. So instead of putting a negative there, I could just write 0 to infinity here, right? And so what I write in place of dx is now just x du. And so I'll write the du. But x, remember, is e to the minus u. So e to the minus u. Jesus Christ, I'm sweating so much. Like, okay, I won't do this again. What's the rest of it, man? Wasn't it like, what was the rest of it? I'm sorry, guys. I'm so distracted. It was, yeah, e to the x ln of x, which we said was, oh yeah, my bad. It was x to the n, so that's e to the minus u to the n, right? And then see, good memory. And then it was negative ln of x to the n. But intentionally, I've included the negative with the ln in our substitution of u. So negative ln to the n is just u to the n. Also, notice that this is, okay, e to the minus u here, right? E to the minus u to the n. So combine two like that, right? Okay. And so next we could write 0 to infinity e to the minus u times n plus 1, and then u to the n, and then du. Be yourself, right? Okay, so we make another substitution, face of resignation. Again. See, this one awesome kid, Jordan, told me that he doesn't need math help. He just watches my videos for like my personality, and now I'm trying too hard. No, just kidding. This is me always. So the substitution is t equals u times n plus 1. One thing I am not is fate. So dt is equal to n plus 1 du. I keep it real to a fault. dt over n plus 1 is equal to du, and then what else do we need to replace u, right? U is equal to t over n plus 1, right? Okay. And in all of this clowning, I have a 1 over n factorial and sigma to work on, right? Okay. Like, yeah, what I'm saying is in front of our integral is 1 over n factorial and sigma n equals 0 to infinity, but, you know, hopefully you was paying attention. Or rewind, it's not that serious. Okay. So we have now, notice my limits don't change. U being 0 means t is 0. U going to infinity means t is going to infinity. And I say that clearly because we're switching from u to t. But yeah, 0 to infinity. And then this is e to the minus t, right? Because that's t. And then u to the n is, u to the n is this to the n, right? So that is t to the n over n plus 1 to the n. All right, that's u to the n, and du is dt over n plus 1, but we've got an n plus 1 here, so we just go n plus 1 right there, right? Because it was n plus 1 to the n, and then times 1 over n plus 1 makes that, right? Okay. And perhaps it is now that we recall we had n equals 0 to infinity, and then 1 over n factorial, right? And then after that is this. Now I could take out the 1 over n plus 1 to the power n plus 1, and the rest of it will be integral 0 to infinity of e to the minus t times t to the n dt, right? Sorry, I don't even know what accent that was. I'm being annoying now. It's okay. Oh, Jesus. Okay, what is it? Yeah, so I have videos on the gamma function, but this is gamma of n plus 1 by definition. And gamma of n plus 1, as I shown those videos, is n factorial. So what I is saying is that this here, the integral part, is n factorial. Oh my God, Lord. Don't say God, it's Jesus. Yeah, okay, anyway. I could do that, right? So n equals 0 to infinity of 1 over n plus 1 to the power n plus 1 is what we get, right? Now, this is the same as writing k equals 1 to infinity of 1 over k to the k. So I'm done, okay?